Hi, everyone, and welcome to the Risk Awareness Week 2021. I'm joined today by Brian Putt, and it is a great pleasure for me to join him in this workshop. Brian, tell us a little bit about your experience in decision making, and especially decision making and uncertainty, because you've done some amazing things in your life.
Yeah, Alex, well, thank you very much. So, yeah, I've worked at Chevron for several decades in decision analysis and worked on lots of major capital projects for Chevron and developed a investment guide for Chevron. It was very probabilistic, and a lot of people have watched this video from George Kirkland, who was vice chairman at the time, and he talked about decision analysis being part of the DNA at Chevron. So when I retired in 2016, I got involved with SDP. I'm now on the board of the Society of Decision Professionals, something people might want to think about joining.
By the way, we do encourage everyone who is watching the Risk Awareness Week to join one of very few associations on the planet that actually deliver value and talk about risk management too. In my mind, it's quite ironic that the only association that talks about proper quantitative risk analysis and decision making does not have the word risk in its title. So it's a good sign already, because every association that has the word risk in the title is usually just risk management one.
Yeah, well, I think SDP is great because they have local chapters at a lot of places. Plus, they have kind of like monthly presentations from people from all over the world on subjects that are quite interesting. So something to really consider. So I'm doing that and helping out with Decision Education Foundation, which is working with youth, because I think we need to, if we're going to promote the risk awareness, I think it really has to be a ground up understanding, and those high schoolers and college people have to grow into the management positions, because when you think about it, the decision quality and decision analysis have been around for 30 years, and the penetration in corporations is not nearly as great as you might expect. So
yeah,
it's unfortunate.
We've never really discussed this, but I am completely on the same page, because one thing that struck me as amazing is that, and I wrote an article, it's called the schools don't teach your kids risk management, you have to do it. And the biggest surprise, or I guess realization for me, was that every problem in school has a specific deterministic answer. Everything is either right or wrong. There's always an answer. For example, two cars leave different cities. What time do they reach if one is traveling with one speed and the other one is traveling with the other speed? I mean, well, as Sam says, Sam Savage, that's the typical flaw of averages. No car is going to travel at the same speed consistently over 100 kilometers. And I was just amazed that the kids have no notion of the fact of uncertainty, is that sometimes you have to pay to reduce uncertainty. And that is, in fact, normal, and it's okay. And it is very brave to pay to reduce uncertainty, to improve your decision-making quality, which is, I think, which is kind of exactly what we're going to talk about today.
Yeah, absolutely. And I think it's really important to have enough information about the information and optionality, because sometimes managers may think, well, I'm paying for this information, I should always benefit from that. And you don't always benefit. Sometimes there's a downside to it. And so you need to recognize that.
I have a personal story to share.
Okay.
My wife is very upset that I'm bald, and she wanted for our 10-year wedding anniversary give me a gift of hair replacement. And she made me go. I obviously don't care, but she made me go to the surgeon yesterday, travel all the way to Barcelona yesterday to check whether it's possible. And he said it was not possible. Apparently I don't have enough hair, and I should just give up hope. And so, but I didn't care. But then she asked me, are you upset that we've traveled all this way to Barcelona to check and the result is negative? I said, no, I'm not. I am actually very happy because I've now received the information that completely takes the uncertainty out of the picture. I know the answer to the question. It may be not the answer I wanted, but at least there's no more uncertainty. So I was very glad that we made the investment to travel and get that extra information. So it's funny how risk managers think and very different to how humans think.
Yeah, yeah, yeah. All right. Shall we do it here, Alex? Okay.
Let's see what's let's talk about what the agenda for today is. And
okay.
Everyone, I encourage you to ask questions underneath this video. Talk between one another. Don't wait until the end of the video to ask questions. Scroll down, write your comments. Anything you want to share, anything you want to participate. Make this Risk Awareness Week interactive. And if you think this or other sessions during the Risk Awareness Week are useful, by all means, just share it with your colleagues. I mean, this is not a conference for risk managers. It's a conference for decision makers that can benefit greatly from decision science and risk analysis.
Yeah, and so, this is, yeah, absolutely. That's absolutely, and we're talking about here applications, actual applications you want to apply in the business environment as opposed to something theoretical. So, So what I want to do today, Alex, is I want to introduce the case study. And then we're going to review the frame just to make sure we understand the opportunity, because framing the opportunity and framing the optionality that might be available in your particular opportunity is really important. If you get that frame too narrow, you're going to miss some of the upside. So we want to just basically cover some of the what I consider to be key framing tools that we have. Then we're going to review the model inputs in the model. And then we're going to analyze the no information case, which you need to do look at optionality, because you need to know, well, how much is it going to, optionality normally costs you money. And so you need to know, well, what am I really gaining from that optionality? And we'll also want to analyze we'll look at imperfect information. Perfect information oftentimes can be done pretty easily in a tree. But imperfect information needs more of a little bit more thought. And we're going to do this using a Monte-Carlo approach using SIPmath. So that's what we want to do today.
Sounds fun. And I'm very thankful to everyone who's watching this workshop, because this is one of the examples where we'll actually delve into the model and we'll show you how it's done.
If there's any questions around optionality, I might point out, this is representative of an optionality, because I have an uncertainty that gets resolved or partially resolved. It may not be perfect information, but then I can make different decisions depending upon the outcome of that uncertainty. So that at the rudimentary basis is the value of optionality, the value of information. So what is the frame of the problem here? Okay, so we're wearing some good clothes, but we do not have an umbrella, at least in hand. And there's a 30% chance of rain that we've understood. And we could buy an umbrella on the way out. And so the first decision that we need to make is whether to buy that umbrella. And if it rains and we do not have an umbrella, then we're going to have to clean our clothes. And this could be very expensive. We could have to replace them or repair them. So that's the downside of not taking an umbrella. But we can delay our departure and get some more information, maybe from the news, the TV, or someplace else, some better information that's going to indicate whether it rains. And this information is only accurate 80% of the time. And so we'll talk a little bit about what 80% of the time means. And it doesn't have to be symmetrical. This is going to be a symmetrical, but it doesn't have to be, okay? And so should we stay for this information and incur the cost to gather that information? That's kind of the word description of the problem.
Yeah, so, and I just wanted to quickly just mention that we've taken this hypothetical everyday life scenario, just like Brian and I do every single year during the Risk Awareness Week. By the way, if you haven't watched, watch the 2020 and 2019 the workshops that Brian did. But think, and this is one of the kind of lessons in risk psychology, is think through the words. We're going to talk about umbrellas and rain, but in reality, it's the same technique that you can use for multi-billion-dollar investment projects. Similar decision trees, similar influence diagrams, similar Monte-Carlo simulation methods. We're talking about the application of tools that are relevant to every single life and business decision. So don't tune out just because it's about rain and umbrellas. This is about the actual application of the techniques behind it.
This could represent a market survey. This could be the selling of a product in a test market, things of that nature, if that relates to a lot of people. Or it could be something that's in the lab, okay, that you're looking at, and the results of that lab test. So what I think is probably one of the key elements in a framing exercise is coming up with what's known as a strategy table. And this could be, I normally write it this way, where I have all these decisions over here. I'm only showing two decisions. We only have two decisions: take an umbrella or buy information. If you're doing this with let's say with an oil and gas, because I come from an oil and gas background, you may have 10, 15, 20 decisions here that need to be made at some point in time. And you think about the alternatives of each one of those. So in this case, take the umbrella. I can either yes, or I can take it, or no, I don't take the umbrella or buy the umbrella. And then I could have a decision whether to buy information or not. So this is not reading this way. It's not reading down. These are just reading across. These are alternatives, because there's really three alternatives. I can don't take the umbrella. So no. And I can say, no, I'm not going to buy information, and take the least costly upfront position. Or I could take the umbrella, buy an umbrella. And if I buy the umbrella, there's no sense in getting in the information. Or I could buy the information down here. And then what I do, the optionality, is whether I buy the umbrella. Okay. So the strategy table is really important. Spend some time about it, working with your subject matter experts on different dimensions of your particular opportunity. So the other way to think about this is a decision tree, and decision trees have been around since the 70s, really. And sometimes visually this helps people understand what it is, but we have three different development scenarios here, if you will. These are the three that we already talked about. And then it shows how, if I buy this information, I get an indicator here. This is the indicator from my information. So this is a rain indicator in our situation. And then based on that, I have to make a decision around whether to get the umbrella. And I can make different decisions depending upon which node I come out here. So I could have put two decisions here, and then going different ways, similar to what I have up here, to be very honest. But it's really important that whether I get information or not, they both see the same rain. And more often than not, I see these values of information, optionality, rain indicators being formulated in the wrong way, such that up here, the probability of rain would be different from the probability of rain down here. And that leads to erroneous results. And then, of course, we have other uncertainties here in this tree that I haven't shown, such as the cost of the umbrella, cost of cleaning, and the cost of the information.
Yeah, but this is the decision tree is a super powerful tool for quantifying uncertainty, because this essentially becomes the kind of the blueprint for the model that you can put in Excel or any other software. And it is so important to write it on the paper and then discuss it with the decision makers. And one of my favorite tools, personally.
Yep. No, you're absolutely right. The issue if you try to solve these with decision trees, the problem is this grows exponentially. And so getting more in about 8 to 10 nodes, 8 to 10 nodes, that includes decisions and uncertainties, oftentimes becomes very, very difficult. And when you've got a bunch of subject matter experts that are involved, it doesn't matter what business you're in, they all feel like their stuff is really important. And invariably, you'd really like to put in more nodes if you could, but you can't if you're using a decision tree because it takes too long to calculate.
Yeah. And that's why we have this next amazing tool, which is even better.
Yeah. So this is one way to characterize it. The other way to characterize it is through an influence diagram. And so here we've got decisions in the squares. We've got the areas that we have to assess the information here in the ovals, yellow ovals. Does it rain is something gets calculated based on the chance of rain. So this is like a 0, 1, and that feeds in the indicator of rain. And then the decision to buy the umbrella if we get information. Okay. I guess I lost my. I guess I lost a node. I had one in here earlier, and I probably should have put one back in here because I don't see how I get to this from this node. Anyway, that's neither here nor there. But the idea is you can use these influence diagrams to explain it to people as well. And it's very useful in lots of different ways. It shows the relationships of the decisions and the uncertainties. You can assign these different uncertainty nodes to various different organizations, whether that to be the engineering department, the finance department, the tax people, whatever it might be. And it can be useful in building the model as well and testing the model to see if it all fits together. So I really like to do these, kind of on my own initially, and then I can share the results. I wouldn't want to do these online with people. It takes a little bit longer. So anyway, okay. So here are the assumptions of the uncertainties. We have the umbrella cost, replacing the close, and the cost of information. And over here, I've shown some PDFs of those distributions. So with that, I think we ought to go back over and look at the model, Alex.
Yep.
Okay.
Let's switch to Excel and see what it looks like.
Okay, so here's our model, Alex. And so I have a particular way of modeling that has evolved over 30 years. And I'll give credit to the SDG, Strategic Decisions Group. I kind of learned from them, and they had a modeling technique, and I've kind of followed that and then augmented it and applied it to Monte-Carlo, if you will. But we'll break it down into, here are the decisions we're trying to make. We need to make the decision on whether to buy the information, and if we get the information, what is our decision policy? We have uncertainties here that we've talked about. Here's that input data we showed you earlier. And in this case, I've already started the SIPmath model. We have this PM table model down here. But what I wanted to do here are 3 uncertainties. What I want to do is I'm going to generate a graph of those 3 things. And we're going to do a cumulative. And then I'm going to combine these. I'm just going to hit Control X, hit that, Control V, Control X, and Control V, and I'll put in the legend. And so now we can see the relative costs of our inputs. Over here.
And this is just for our viewers who've missed Sam Savage's presentation on SIPmath and chance calc. I mean, this is just the beauty of working with uncertainty in native Excel. I mean, this is the power that SIPmath gives you. You can copy paste distributions into just normal graphs.
Yeah, yeah. I mean, I'm not saying that other Monte Carlo software couldn't do this, but I think the effort required to do so will be much greater. And this was just, I mean, I didn't do anything special here. This was just out of the box, right? So we have that. And so now what we said we're going to do is we wanted to calculate our deterministic model. And let's see, let's look down here. What do we have? Okay, here is the total cost of not buying information and no umbrella. Let's see what's here. It says if not buying the umbrella and not buying it. So if it rains, then I need to incur the cost of the cleaning the suit, which is in this case 2207. And if it doesn't rain, I don't have any costs at all. So in this particular case, it's 2207. And with SIPmath, I can look at different trials. And so that happens to be trial 57 of 1,000, by the way. And so there's trial 58, 59. See, this 76 corresponds to that 76 up there and so forth. So there's 1,000 of these
Okay,
things.
so that's interesting. I thought that was the average, but no, it's just each trial is a separate entry.
This is the deterministic model here, Alex, in this section. Down here, you can see that we have a probabilistic section as well.
Makes sense.
Yeah. And then if the total cost of not buying info and buying the umbrella is simply the cost of umbrella. And the umbrella also has an uncertainty, so you can see that that one's moving as well, right? All right. So now that we've got those two, let's define those as outputs. These were already defined as outputs. So let's define these as outputs. And let's define using these names here, okay? These are a little bit shorter than these names. We could use that, but that's too kind of long. And then there's something called spark lines. That's these little blue things in the middle here. I like to use those as invalid character. It's invalid because there's a space in here, so we just say yes. And so now we have, oh my goodness, look at those spark lines. Those are not very normal looking, are they? Not very normal looking at all. So why don't we plot those things? Once again, we'll plot some CDFs. SIPmath does make histograms, but I don't really like the histograms. They're not very good. Once again, I'm going to cut that and paste it in here. And so now I can look at the legend here. Sorry. Get the legend. And so we see that the blue line, if I get the umbrella, it's got a very small uncertainty. That just corresponds to the umbrella cost.
Yep.
And if I don't get the umbrella, I've got that 30% chance of rain. And if it rains, then I have to pay for the suit. And at this point in time, with this particular chance of rain, no information with the umbrella is actually the best. It's the lowest cost. It's 11.6 expected value rather than 13. But if you're risk seeking, you can go with the red line. But it's got a higher expected cost. Okay. So let's talk about the value of information. So the information cost. So now we're working on a deterministic. So if you're used to doing deterministic models, Alex, this is no different. You're just writing a deterministic model, and then we're going to, because there's an uncertainty going on, we'll convert it to an expected value with a range, okay? So what is the information cost? So Alex, the information cost is equal to this cost of rain information. So in this case, it's 0.8. But, well, this is I'm buying information. So by definition, if I'm buying information, I have to pay for that. One way or that doesn't matter. Now here's the umbrella cost. I can't do the umbrella cost because I don't know whether I'm buying the umbrella yet. So let's think about this influence diagram, right? I'm going to come back here. And what I've said is that the chance of rain impacts does it rain. And if it doesn't rain, then I impacts this indicator. Okay. So in a information perspective, I can calculate the rate, whether it rains or not, get the indicator, and then only use this indicator to make the decision. I'm not using the reality here to make this decision, only the indicator.
Mm-hmm.
So we're going to come back here to this model. So what this 80% reliability says that if it actually rains, this is reality over here. This is reality. If it rains, there's an 80% chance that I'll say it's going to indicate rain. And a 20% chance I'll indicate that it's not going to rain. And if it's not going to rain for reality, it's the opposite of that. That's what the 80% is. But this does not have to be symmetrical. So these by definition have to add to 100% going across. Now, does it rain? Well, here is this chance of rain. And over here, there's a variable that says that if this random variable 0.62 is less than H, 10, then there's no rain. Okay. So if I looked at some different trials, probably I can get let's see if I can get one that
yes.
Yeah.
Just here.
Right there. Now it rains because this is a 0.22 less than 30%. Okay. Perfect. So this rain corresponds to a 1 over here just because we had rain and no rain here. So the umbrella, so over here we're going to say equals, we want to, since this is rain, we want to use this first row. So we're going to say equals index of these two things, comma, this 1. I'll hit an F4 here and make that a $. So that brings up an 80% and copy that across. And so if I went up to another trial here, we can always, the nice thing about SIPmath is it's as you make a model, if you want to test it, you can really test it easily. Now you see it's no rain, and so now I picked up these two columns.
Yeah.
That's so anyway, having done that, now there is this another uncertainty here. By the way, these uncertainties are all uniform. These are uniform distributions. And this is a Doug Hubbard contribution from his company that generates random numbers. It's been tested by him. He's like a statistician sort of guy. Anyway, so
he's also a speaker at the Risk Awareness Week.
He's also a speaker. Fabulous, because he's not going to just probably talk about uniform numbers. He's probably going to talk about something much more esoteric than that. So anyway, this is 0.85. So in this particular case, what is the answer? It says equals if this is less than or equal to that, then it's it indicates no rain, right? Otherwise, it's going to indicate. Excuse me, I said that wrong. If it's
the other way around.
Yeah, but this is getting the right answer because this is greater than 20%, so it's indicating no rain. Okay. So now this we'll just indicator of rain. We'll say equals this. I guess I could have done the calculation up there, but now we're so there was no rain indicator. It doesn't really rain. The indicator said no rain. That's a good outcome, right?
Mm-hmm.
Yeah.
Means our investment in the information was justified.
Maybe, yeah, maybe. It
Mhm.
it gave us accurate information. Whether it's
Yes.
justified economically is another issue, right?
Exactly.
Okay. So now we can come down here. Now, now we have to talk about the decision policy. So is there any situation where if it said indicates no rain, is there any reason why you'd buy the umbrella? Not really.
Yeah, I guess.
That wouldn't make any sense. If you're going to buy the umbrella if it indicates no rain, and you're going to buy the umbrella if it says rain, then you might as well just go buy the umbrella and not get the information.
Yeah, true, because the information costs up to $10, which is average of what the umbrella costs.
Yeah, right. Okay. So this is equals if this equals indicates rain, then we want to buy underscore information, I guess. I really don't know what, I'm not sure what the other one is, what the other alternative is.
I think it's buy umbrella, because
Buy
we're
umbrella?
already, yeah.
Okay, buy umbrella.
No, I mean the previous one is, it's not buy information, we already bought the information, so it's just buy umbrella.
Buy umbrella. Well, we'll try that, see if that works. Yeah, we got an easy way of testing that, by the way. See, we'll come up here and does this have a down arrow key? Oh, no, it doesn't. Oh, my goodness.
Right, try different trials.
We'll try different trials here, okay? Yes, it says buy information. Let's see what it said before. It said buy umbrella. Okay, we'll go with that. All right.
You just have to, let's check the formula in D7.
Delta
if D7, yeah. So if I understand it correctly, if the indicator rain equals to D20, then it should be buy umbrella. Otherwise, it should be don't buy. It should just be buy umbrella, not buy umbrella. Because if I'm correct, this is the decision.
Right. Yeah, okay, that's right. This is buy umbrella, we buy umbrella. How about no umbrella? I think we may say just no umbrella. And I have to put some quotes around here. All right.
Are they the right way around? No umbrella, buy umbrella? If indicator rain is D20.
Then we want to buy an umbrella, right?
Yeah.
Thank you, Alex.
I just hope everyone's watching is paying as much attention as I am.
Well, no, I think this brings around a really important aspect of modeling. Having two of us work this model and actively being engaged allows us to find these errors right away. Okay. Rather than,
I totally agree.
Rather than doing a bunch of modeling, at the end of the day, you say, well, now let me run my Monte Carlo, let me run my tree. And oh my God, that tree doesn't make good results, don't make any sense. And oh my gosh, what do I do? Now I got to go back and find it,
And absolutely agree. And this is one of the most important lessons that I share with my team all the time. It's important to sanity check your models as you build them. Instead of just waiting for the final calculation and then trying to guess whether that calculation looks reasonable or not. Because with a simple model like we're discussing now, the conclusion will either be buy umbrella, not buy umbrella, buy information, not buy information. And it is quite difficult to pick up from that whether the model has an error inside it or doesn't, because both answers look reasonable. And it is absolutely critical to sanity check along as you go, because we've picked up so many different issues when we're building complex like environmental models. I'm glad we're talking through the calculations.
I hope you don't take an objection to this, Alice, but I think risk managers have gotten really good about telling stories. And so you get the results out, and you find a story that matches those numbers. So.
Oh, for sure, for sure. I one of my special skills is packaging risks and selling them to insurance markets. So yeah, I can sell any risk on the planet. Yeah, absolutely. But at the end of the day, you have to be pretty confident in the quality of your model and your decision before you present it to the decision makers. It's one thing kind of selling it to the external stakeholders, and it's a completely different story using it internally for the actual decision.
Yeah. I tell you what I want to do here, Alex, is I'm remiss. I was remiss in not in documenting this better to start with. So let me document it now, and to say that those are the two options there, right? And we may need to expand these a bit. These two columns, or I guess we could have wrapped them as well. But, okay, so we got a buy umbrella and no umbrella, right? Okay. So now umbrella costs equals if my decision policy, if this thing equals buy umbrella, okay, I'm going to fix that. I'm going to help you there. Then I want to incur the cost of the umbrella.
Mm-hmm.
Otherwise, I don't. I could have done this with binomial distribution, but I think a lot of people. Now, you see that H7 is not really very beneficial. So if I click on that and hit F9, it fills it in and then hit the enter key. And now it says, if the variable buy umbrella info says big buy umbrella, then I incur the cost of the umbrella. That's like an English statement. That's really easy to follow.
Yep.
And you really want to have these models being as transparent as possible, because a lot of people should be looking at them. And unfortunately, a lot of modelers are very hesitant to share their models. I think they're concerned that people are going to find an error. And so
there's nothing more intimate than a financial model from what I discover in business.
Yeah. So I mean, I'll just share this information. We had a process where we audited, or not audited, we had a peer review of models. Oftentimes companies will have a peer review of the project. They bring in subject matter experts, but they kind of look at the technical side of it and so forth. They don't actually look at the model. But we had a peer review of the model itself, and I thought that the modeler would be reluctant to do that. And what we found right away is, because of the way we went about it, it was about the model and not the modeler. They were very receptive to it. Okay, so now these cleaning costs. We incur the cleaning cost when? Let's do this with the binomial, okay? We incur the cleaning cost. I guess I could say buy information, but by definition, I'm buying information here. I incur the cleaning costs if buying umbrella is equal to no, I don't have an umbrella, right? And it rains. So this variable equals, I think it's rain. I think it's the word rain. Yeah. I think so.
Yep.
And then we'll do the same thing here, I7, F9 it. So this reads, I incur the cost of the cleaning if buying umbrella info is no umbrella. So I didn't buy the umbrella and it rained.
Mm-hmm.
So I think we really ought to test that one. So we'll kind of look at a couple of things here. My goodness me. Oh, well, I guess maybe this isn't working yet. Maybe we need to get, that's not a good, oh, there we go. Let me go back one. There's the 34. So I incurred 34, okay. And I didn't get an umbrella and it rained. So that was the right combination. So that seems to be working, right?
Yep.
So here's my value of information equals the sum of these three things. Okay. And now I want to define this as an output, just as I defined these as outputs. Define that as an output. And this has invalid characters, no problem. And then I'll generate the CDF chart.
It's fine. You define the name.
I understand. I'm going to show you how to undo that. I'm going to undo that. I'm going to clear it using this clear button from SIPmath. And I'll get rid of this graph for the time being. And then I'll come back here and I'm going to redefine this. SIPmath, define outputs. The output name is value with information, right? And then I will graph that. There we go. And now what I want to know is how does this compare to that? So I'm going to combine. This is the one I want to put in with this. So I'm going to cut that and stick it in here. There we go. There's one of your key outputs here. And this is cost. The nice thing about these graphs from SIPmath is because they're straight Excel, you can manipulate them like you normally would an Excel graph. There's nothing special you need to do. Yeah. So
yeah, what is this graph telling us?
Well, with the information, it's the green line. And that green line has an expected value of 11. We can get let's get a few more decimal points here. I need to get out of that chart. Over here, SIPmath. And then over here in decimals, we'll just put in 2 across the board. All right. And what that's going to do is when I come back over here to my model, I now have some more decimals here. So we can see the value with information is 10.85. And with no information and no umbrella was 13. And no information with umbrella is 1164. So this
that's the value. I mean, it's not really a value; it's a cost to us. So the lower the better.
Yeah, that's right. So normally, Alice, when people talk about the value of information, they oftentimes you'll see in a PowerPoint a scale, and you've got these two things that are going back and forth, right? So now, what do you see as the value of? I've given you the information here. How would you tell me? And these are expected values, by the way. How would you, if you had to give me one number for the value of information, what number would you give me, or how would you calculate it?
I don't know.
Okay.
I'd be probably reluctant to use averages, but let's see.
Well, the typical way of doing this is if you're in a decision tree mode. Okay, let's come back to our PowerPoint here. What you would do is you'd get an expected value here and for all three of these things. And then it's really important to, in this case, to use the lowest cost alternative. Okay. So, and then you would take the difference between buying information and the least cost alternative, to get the value of information. So in our model now, the least cost alternative is this one here, the blue line, no information with umbrella, 1164.
Is it, sorry, is it the list cost or is the value with information the list?
This 1164 is if you do not have information and you
Okay,
buy
yeah,
the
yeah.
umbrella, right?
Yeah.
That's the least cost alternative if you don't have information.
Yes, correct. Yes.
If you
Understand.
get information now, it's 1085.
Yeah.
So I'm going to say, I just put over here, the VOI is equal to 1085 minus 1164. And that doesn't work that way, does it? So this is the value of information, EV. So I save 0.79 by gathering that information.
So 79 cents.
79 cents,
Oh,
yes.
in our particular case.
In our particular case, yes, that's right.
Yeah.
However, you'll notice that, you know, there's an awful lot of upside here by getting that information, or at least, value with information. This is the cost. This is actually cost, isn't it? So even with the information, there can be a large cost. So why would that happen?
Because the information is only 80% accurate.
80% accurate, right? So what happened here was I was told the new information said it wasn't going to rain, but in reality it did rain. And when it did, when the information said it's not going to rain, I didn't buy the umbrella, and it rained, and I had to go clean my suit. So understanding these tails is really important. We talked about this tail, and we said this is just the cost of the umbrella. And so it obviously if there's a minimum cost here, just getting the information. So this is really never zero like this red line is. Okay. But now let's talk about something else. Okay, so we said that the best case was the no information with the umbrella, no information and no umbrella, and with umbrella. So let's calculate this one. Equals. Now I need to say here that I'm doing this at a trial level. I'm doing this at a trial level. So I'm going to do that. I'm going to calculate 1,000 numbers here. And I guess I should have said it somewhere along the line that every time I hit in the enter key, it's actually recalculating 1,000 things, by the way. That's how fast computers are these days. And the way SIPmath does the calculations using a data table internal to Excel. So this is equal to the cost with information minus the cost no information with umbrella. We said that was the least costly over here, right? Okay. So in this particular case, I had an incremental cost of $25.96. So $25.96 is, over in this range.
Sorry, what's the formula? 35 minus 39. Not by infinite. Should this formula be in this cell above? In 41?
Well, this is comparing no information and no umbrella to the value. The no information and no umbrella had a higher cost.
Yes.
Well, I'll tell you what, let's do that. Let's calculate both of these, okay? We'll just do it right now. We'll do it right now. Do that one, right? Well, that's a better answer here. That's a better answer.
Okay, yeah.
Okay. However, remember, these are deterministic. So if I look at these on is trials. Well, whoa, now that one's not the best answer, right? In fact, like down here, I saved a whole bunch of money. I saved $11.
Yeah,
Down here.
because it didn't rain and they didn't buy information.
Not clear. Well, let you ask that. Let's check that out. Here it indicated no rain and there was no rain. So, and I said no umbrella. So I didn't buy the umbrella. You're right. Yeah. Okay. So now what I want to do is I'm going to define these as output variables.
Mm-hmm.
So I'll come over here to SIPmath. We'll define these as output with these names here. I'll try to get it right this time. And now let's plot these, okay? And I'm going to combine these. So I'm going to hit an X there and hit a V here. Okay. Legend. Okay. And once again, let me come over here and give these some more decimals. Your first reaction might be, well, clearly the no umbrella case, we have a higher value of information. So did we say something wrong earlier? Here's that 7, we calculated as 79, didn't we? Here's that, see that minus 79? There's that minus 79 that we calculated. Well, why do we think that's the right answer rather than this one? Let me give you an example, Alex.
Yeah.
I have an upset in my refinery, and I need a part to fix this unit. And I'm trying to justify the cost of that fix on that unit. And so I make the assumption that the refinery can't run at all until I fix that unit. And the subject matter expert raises his hand. Well, sir, that's not quite right. We can run all these other different types of units and still make some types of products. We just can't make everything right. And we'd still have revenue. So doesn't that sound like the better alternative? Do I really need to, I have to pick the right reference case. If I pick the worst reference case, you can justify anything, but you've got to find the best reference case. In this case, the best reference case is the lowest cost. And the lowest cost was this new information with the umbrella at 1164 versus 1334. And that's why this blue line is the right answer.
This is actually this is very interesting and very on point. I've just last week I sent a letter, our kind of corporate feedback to the Ministry of Natural Resources, and my point is that when you use the worst case scenario, you can justify literally anything. But that's not quite right, because the worst case scenario is actually highly unlikely. And there are the whole distribution of possible scenarios, and you have to take into consideration the whole distribution, not just one extreme case to make your point. And that changes the point completely most often, because if you just use one reference case, which is horrible, then it distorts the kind of the whole decision.
If I had to relate your comment to this chart, it would be like saying, let's just look at one trial in here. Darn it. Here we go. Here. It's like you took this data point and you say, look, clearly we shouldn't, but the reference case is no umbrella because this saves us 19 here versus this 67.
Yep.
Okay. Where in reality, the exact opposite is the case. we see
This is
that,
why deterministic decision making is so limited.
yes. And now, just like we're doing here, interactive with this model, my vision is that with your project manager or whatever, he's going to have these questions, and because you can show him different trials, he can get the flavor for there's really a lot of uncertainty, and you need to look at these CDF charts. And I've had lots of people say, I would never show a CDF chart to my client, okay, as a consultant or whatever. They don't understand them. And my answer is, well, take 10, 15 minutes to explain it to them. And then that this world is your oyster, you can compare things much more easily. I mean, how can you back here I've got three PDF charts. There's nothing to compare them. It's very difficult to compare them to because I've got to go look at these scales down here. Whereas over here on this chart over here, now we see the relative costs of these three things. So the CDF, to do good decision analysis in my mind, whether you're doing monte-carlo or whether you're doing decision trees, you need to put things into a CDF, okay? I'd like to demonstrate something. Right now we said, so here's this chart, and we're looking for the smallest number here, because this is better down here. This is better. Okay. So now what I want to do is I want to change this to a different number. So rather than we've been using 30% probability array. Let's change this to 20%.
Yep.
So now by 20%, using that same blue line, it looks like it's even more valuable, right? But is that the right answer? What is our reference case now? Coming back down here and looking at the red versus the blue, no information, no umbrella. It's better. In other words, if I told you that the chance of rain was 0, no, at least it all worked. I wasn't sure it was. If the chance of rain was 0, is there any reason why you would want to go get information? Doesn't make any sense. On the other hand, if I told you it was 100%, why would you want to go in get information? You would just go take the umbrella.
Yep.
I mean, once again, this comes back to the statement you made, Alex, is as you build these models, you want to test it for, does it satisfy your gut? Does it make sense at a high level? Not just the numbers, but just conceptually. So I mean, 100%, getting the umbrella only has a cost of 11 versus 46 without the umbrella. Okay. So let me kind of jump to another slide, Alex. We'll kind of shortcut this a little bit. It's this one here. What I've done is calculate the cost, the value with information, or the cost with information at various chances of rain.
Chances of rain, yeah.
Yeah, it comes this black line. And then I've also calculated the cost if I buy an umbrella, which is a flat line. It doesn't matter whether it rains or not, so I get the same answer. And then I've calculated the cost if I don't take an umbrella. I didn't take these out to 100%, but adequate. The point I wanted to make here, although we said that this information had value at 30%, which is right through here, what we're really interested in is this envelope. This envelope, it's the lowest of these lines. So it comes up here through the blue, then hit the black, and then over here it switches to the red. So the information on rain only has value between about 22% and let's call that like 30%, 35%. If it's outside that range, the information on rain has no value.
Because the decision would be almost as obvious without the information.
Right, right. You want to do the other, you down here, you wouldn't want to take an umbrella, right?
Mm-hmm.
And if it's higher than 35%, you would take an umbrella. The information is not going to change my decision. Alex, at this point in time, do you have some other questions that I could try to address for you?
Sure. I wanted to kind of to bring it all together and make some valuable conclusions. First, deterministic decision making has a lot of limitations because it shows us one possible future at the time, and the way we select those futures really influences our decision much more than the reality. And this is what I call, traders versus risk managers way of thinking, because traders, they think of a future and they believe into that single version of the future, and then they go around and try to convince everybody about that single scenario. And then the risk managers approach is that risk managers appreciate that there's uncertainty in a lot of the things. And in fact, there's not a single future, but there's always a distribution or a set of distributions of the future. And most of the time, the volatility around that favorable or preferred or base case is much more important than the base case. And what really surprises me in business is that many businesses still operate, and our personal decision making still operates in the mindset of a trader is we want to think of the best, most plausible future in our mind, and then we just bet on it. And in my risk management mind, this is just pure insanity. Is we put so much effort into guessing the best possible future, most probable future. Let's even rephrase it. But it's still just one scenario, and then we bet everything on it, which is in my mind insane. Because as a risk manager, I think it's much more valuable to pay for the extra information if it's justified to reduce the uncertainty. But to reduce the uncertainty, you first have to understand how great the uncertainty is. And the only way you can do it is stochastically using some of the techniques that Brian was discussing, which is decision trees, influence diagrams, and Monte-Carlo sitting on top of it. And this demonstration showed that buying or not buying information is actually a quantifiable question. And this is what I'm, as my professional experience develops, I'm still quite young, and I learn new things. And one of the new lessons I learned is that most decisions can be quantifiable. You don't have to guess. You can actually calculate. You can make some assumptions, and it will be not necessarily a single answer. It will be a distribution, but at least you can narrow that uncertainty. And most of the decisions are calculatable. So getting additional information doesn't have to be a gut feel. You can literally, Brian just showed you that you can calculate if the uncertainty is between X and Y. In our case, it was 22% of the chance of rain and 35% chance of rain. If the uncertainty is within that range, you know that it is worth paying for the extra information. That is, in my mind, is very valuable to take this uncomfortable gut feeling out of the decision, because you know that within certain parameters, it's a good decision to do, regardless of the for the cost of that information. Because if we were changing the cost of the information, I'm sure the range within the value of information would have changed as well. But within the parameters you're given, many decisions are quantifiable. And one of the last examples I had is we were deciding what deductible to set on our global cargo insurance program. And it was funny because we've asked the head of trading is what kind of deductible do you feel like you feel comfortable with, because the shareholder has a very high risk appetite, but then the traders on the ground have very low risk appetite. You're the head trader. What's your feel? And he went with the natural human tendencies to choose the middle between the highest option and the lowest option. But the funniest thing is that we had the full distribution of the incident data. We had more than 1,000 data points. So we actually had a full risk profile. We quantified, given the cost of different deductibles and the cost of premiums, and the actual risk profile, how much risk we retain on the different options. We just did a very simple calculation and showed that, again, complete coincidence, but he guessed it right. Because the option that he selected had the better return. 78% of the time, it would be a more valuable choice than the other options. And again, he wasn't sure 100% of the time, because you can't be certain 100% of the time because the risk profile is probabilistic. But he was correct 78% of the time, which to me is more than good enough for making a selection under uncertainty. And yeah, amazing. And I think that this is the takeaway from this session, and the takeaway from the Risk Awareness Week in general. You can quantify uncertainty. Uncertainty is not this unknown, scary animal that you should only rely on your gut feel and do nothing about it and just surrender to uncertainty. That you can tame uncertainty. This is, I think, what risk awareness.
Let me take it from a possibility of $10 to gather information to $100 million to gather information. So
yeah, exactly.
I've got a field that I'm looking to develop. I've drilled 2 or 3 appraisal wells. I've got that information, and now the question comes up: should I drill another appraisal well that's going to cost me $100 million? How do I make that decision? How do I make the decision to drill another appraisal well? Because I could take 3 actions here. I could say, based on the prior information, I do not want to develop this. Or based on the prior information, I definitely want to develop it. Let's just go for it. We'll go into feed and develop it. Or the third option is, no, let's spend the $100 million and drill one more appraisal well to get some additional information. They're identical to our information case with the umbrella.
Yeah,
but it's $100 million decision, not a $10 million or $10 decision.
Yeah, and that's a tough choice to make based on the gut feel. You have to put in the work and the effort into calculating the value of information. But the irony is that the methodology would be exactly the same. Decision tree, influence diagram, monte-carlo model.
Right. So this may seem like a really simple example with the umbrella, but I think in reality, if you think about how it applies to your business, whether it's the insurance business, the marketing business, appraisal well business, it's all kind of the same thing. But you've got to understand how to do it and make sure you get the right reference case to do the calculations.
So please ask questions, write underneath this video, write comments. If you think this video is valuable, share it with your colleagues in work. And we thank you. Thank you very much, and see you in other risk awareness sessions.
Thank you, everybody. And thank you, Alex.
Thanks, Brian. Bye.
Okay, bye-bye.